Right, ladies and gentlemen, welcome back to the pre-launch session for TechWeek 2016. I would like to thank Brian Basil for designing this outside route and coming north of the river to TCU. TCD sucks. But he's here to talk to us today about Prometheus, and he's actually coming in as professional guys from Robust Perception, which is your company?
Yes, my
company. You've done this talk, or this talk has been done as a Google talk before? Apparently?
No, it hasn't.
No, this is the first time?
Yeah, but this, I customize every talk.
Oh, yeah. We're honored. Some of you, the older and more gentrified members of our associate ranks may know him as Basil from Interdocs and over the years. Welcome to GCU and thank you very much for taking your time. Excellent. Ladies and gentlemen.
So, as was introduced there, I'm one of the core developers of Prometheus. I founded my own company. I studied ECD and CS. I've been there in Trinity NetSoc, from IRC. I founded the company, Robust Perception, so we do commercial support for Prometheus. And I worked at Google for 7 years after I was in Trinity, so I was looking at the monitoring systems there, managing them, dealing with things go wrong, dealing with a billion metric systems that have to scale up and deal with tens of billions of dollars of revenue a year, which is always fun. Mostly because you need monitoring. Goes wrong. So why do you monitor? So there's a few reasons. Because monitoring means different things to different people. From we're going to get a whole pile of very expensive humans, put them in a room, and get them to look at screens. That's a really good way to use humans, especially expensive ones, like engineers. So just to clear what I mean by monitoring, and there's 4 things you're aiming for. One is you want to know when things go wrong, and so you can call a human to fix it, or a little in advance, like something like fill up disk space. I want to cache that a little bit early, because most things will fall over hilariously when they run out of disk space, and Prometheus isn't that list currently. We'll fix that someday. Also, don't run out of disk space. You want to be, once you know there's a problem, you want to be able to debug it and know what's going on, so you can go and fix it. If you're making software engineering decisions or systems architecture decisions, you want to know what trends are over time and all the ratios. You want to know how many people are going down the hot path versus the cold path in your code, so you can make decisions based on that. You want to know, hey, 10% of our people are paying with MasterCard. Maybe we should get a better deal on that. And sometimes you just want to feed stuff into automation, like, hey, that machine's failed. Let's go for send a human or a robot to go fix it. So those are kind of the 4 things. Mostly focusing on the first 3 here, so we know things go wrong, be able to debug, and so we can do some trending and analysis. Because the thing is that if you look at many approaches that are taken out there with, say, like nagios or so on, people are just looking at the very edge, just saying, hey, is it turned on? No. Is it turned on? No. Is it turned on? Yes. Okay, it's okay. And that turns out to be very flaky and very noisy. And a great way to get waken up in the middle of the night for nothing. And it ends up with something that's called pager fatigue, where you're paged and you ignore it. If you're ever in a situation where you're getting a page and you're ignoring it, you're doing it wrong. You should be reacting to every page with a sense of urgency and take an intelligent action based upon it. Like something that actually requires intelligence, not something you get a 4-year-old to do. Because that 4-year-old can be replaced by a script. So we've got here, it says Blackbox monitoring. It's monitoring from the outside. So that's your nagios, is your classic example. It doesn't know how the application works internally. It's just, say, visiting over HTTP, doing a ping check, checking if there's an SSH banner. Pretty simple things. And if you've got some sort of pipeline system, it's good to put a record in, get it around the pipeline, see when it comes back out again. That's also a nice heartbeat system, although it's getting a little white box. So where Blackbox is useful is basically you should treat it like smoke tests. It's a way to tell you if things have gone hilariously wrong. And it's also a way to detect things you're not going to detect other ways. Like, if you probably want something outside your network, checking that your BGP is okay, your routing, checking that your load balancers are okay, all the way to your application, and that path is working, because doing that by other means is kind of hard. So you want some basic checks that things aren't hilariously broken. It's not good for knowing what's going inside your system, because all it can tell is, yep, I tried this request, it worked. That's all it does. And you shouldn't try to get it to test everything, because that ends up like regression tests. And especially when you're talking about things going over the network, that turns out to be very flaky. And black box monitoring can only tell you yes or no. So tuning that gets very hard. So this shouldn't be relied on for main monitoring, but it's good for detecting when things are hilariously wrong. So the complementary part to black box monitoring is white box monitoring. And this gets information from inside your systems. And that means CPU usage, number of requests triggering a certain code path, anything you want, you can basically get out of your application. So because the thing is that previously I was looking just at the outside of Blackbox. Your services have internals, they've got all these little subsystems inside them, and this is all hooked together fractally as you go down from, oh, here's our systems level architecture, down to our code level architecture, down to this library has all these classes. And you want to kind of monitor all of that. And Prometheus does is inside each of those libraries, you'd have a little bit of Prometheus code saying, hey, here's all my metrics. I can implement them, and Prometheus will grab them all. The other thing it does is that it doesn't talk about things like just as machines. So if you look at a system like, say, Zabbix or to some extent Graphite, or Nagios actually is a better example, it thinks purely in terms of machines. So if you have a single machine that's running one part of your MySQL slaves and it fails, even though the rest of the system's down, it's perfectly fine. Your only choice is to page on that because it can't do any better. Whereas we can say, hey, actually latency is fine. We can deal with that tomorrow or next week or whenever we are hungover after the weekend, that's fine. These are all options. So Prometheus itself was inspired by Google's board monitoring system. It was started in 2012 by ex-Googlers working in SoundCloud. It's a fully open source project. It's not tied to SoundCloud. Because an interesting thing is that when Googlers leave Google, they start recreating Google technology. I personally have worked on versions of Borg, Chubby, Borgmon obviously, a few others as well, Bigtable, better known as Aurora, Mesos, Zookeeper and Cassandra, and Prometheus obviously. It is mainly written in Go, which is Google's language. It's pretty nice systems programming languages, and the UGC stuff they're doing makes it practical for all but true real time. So if you want to do systems programming, it's a good choice. And we publicly launched just over a year ago in 2015. There are over 100 companies using it. There is a public list up on our website, but DigitalOcean have gone like all in on it. Ericsson, Docker, CoreOS are big on it as well. Lots of companies. Lots of companies I can't mention, especially when we record it, but we can talk about afterwards. So the Prometheus community, it's very active. So we've got 22 core repositories. That's things that we maintain ourselves. Although granted, one of those is just really saying, no, look, this other repository. And there's about 250 contributors inside the last year since we open sourced. So that's pretty good. So it means we're getting like 20 new contributors a month since we launched, which I think is a pretty darn healthy open source project. There's also 35 third-party integrations because we can't support everything. So it also means we're getting about 3 new integrations a month, so about 1 a week. So that's also pretty sweet. So let's talk about what Prometheus actually offers. So there's a few topics. Going through inclusive monitoring, its data model, the query language, how you can actually run it, and how it doesn't suck when you do that. How it's efficient, scalable, how it's easy to integrate with. As I mentioned, we've got 35 integrations, and that's out of date. I think it's probably like 40 by now. And dashboarding options. So inclusive monitoring, if you go back to that image I had of your system, a lot of people will just monitor at the edge. They'll just monitor and say, hey, here's the HTTP request going in. Then magic happens, and it talks to Postgres. Great, so what happened in the middle? No idea. What I think is that you should instrument everything, right? If you've got, like, let's say your company has an RPC library. Instrument it. One person goes instruments that library, then everyone in the company, because everyone's using one RPC library, right? Automatically gets those metrics. Or a DNS library, whatever other libraries you have, even your business logic, instrument it all. And it also means that, well, because everyone's using the same RPC library, because you should do that, and someone's already done the instrumentation once, now everyone has that instrumentation. And someone can pre-create dashboards from that. Or maybe you're a library author. Okay, you have some obscure library that the RPC library depends on and no one cares about much. Like, let's say the compression library, right? Most people don't care about the nitty-gritty there. But you can have a few metrics like, hey, how well is that compression working in various types? And you can use that to tune that, because you can go to everyone's systems and say, hey, how's the compression doing? And then you can make engineering decisions based on it. And it also means that you can just build stuff out of the box to make it magic. That if you do care about it, for some reason you want, let's say, JVM metrics, you have a dashboard right there. You want your personal HTTP library instrumented, off you go, no problem. Saves you time. Now, when you're talking about how you're instrumenting your code, there's several common approaches if you look across the open source and commercial worlds. You've got custom endpoints to dump stats, like JSON or CSV. Like HA proxy actually supports both of these. And it's well defined, and it's actually reasonably good. You can have ones that have a mildly standard implementation, which is JMX. JMX is a standard. it's a way to marshal data. It's not standardized beyond that, which is great fun. You have libraries with hooks, so I forget the name of it now, but Netflix is one for Astyanics, which is Netflix's library for using Cassandra, has a hooks there so you can add in monitoring. So you can hook in there if you want to hook something in, and don't, which is unfortunately a rather common option. So I get all this stuff here, and the thing is that if I'm a user and I have like 20 different pieces of software, each using different approaches here, that sucks, because I need a way to monitor all these. And, you know, do I have to add shims at the right? Do I focus on integrations? Then me, you know, as a core developer in a monitoring project, I want to monitor everything. I want to monitor all the things. And that's why we have like 50 integrations token. Because you need to write individual ones for everything. Which also kind of sucks, because, well, I'm just one monitoring project. There's at least another 15 open source monitoring projects out there. There's another about 40 or 50 commercial ones. Like, this is insane. For everyone. And so, the way I'm trying to help this, one part of Prometheus, is that our client libraries, like the things you instrumented, are open. They don't tie you into Prometheus. So if I am using the Python or the Java client, I can get it to output to Graphite. It's actually slightly fewer lines of code, just because that's the way it works out. In Python, it's a single line less, so like it takes 2 lines to go to Graphite, it takes 3 lines to the HTTP server. Actually, cool. Isn't it? Actually, no, I think the Graphite's one lower. Java, HTTP is annoying, Graphite's simpler because Java. But you can just get that data out there, no problem. So you can take advantage of our integrations and spit them out the other end. So like, if you have systems out there, it's pretty handy. That you don't have to create a new standard, you can just instrument a Prometheus, and then users can hook in and push out to whatever else they want. So you don't have to worry about this as a library alter. And you can do this gradually over time. And of course it goes the other way too, because let's be honest, no one's ever going to switch totally to Prometheus. The entire ecosystem is never going to switch, right? It's too large, too much politics, too much business involved. But that's okay, because we can take data into Prometheus as well. We've got integrations with things like Graphite, JMX, Dropwizard, CloudWatch, New Relic, or Syslog. All these things, there's integrations with. If you do, and you can use Prometheus as a clearinghouse. So if you have data pulled into these, like you can use the Python client to grab that data, convert it into whatever you want, and spit it out to Graphite. If you wanted to do that for some reason, you can do it and just plumb everything together. An example of this, Zalando's, they have a tool called Zmon. Think of it like Nagios, but in Python, and scale that a bit better. It uses the Python client from Prometheus to get some data from, I think it's CAdvisor. Might be JMX or Cassandra, one of those. Just like they're not using Prometheus elsewhere, oh, they are a bit, but they're just hooked it in. They'll be able to take advantage of the fact that, well, CAdvisor is instrumented with Prometheus metrics. And then they can use the Python client to hook in their Python code and just get those metrics. No Prometheus involved. So those are the advantages that someone's written code once to make this all integrate nicely. And the other thing is that you come across lots of instrumentation clients, or things that are called instrumentation clients, and all they do is they marshal data. That's all they do. You have to actually worry about all the bookkeeping. Like, how do I count? How do I do concurrency? How do I time things? You have to do all that. That's silly. So the Prometheus ones actually care about getting this right and making this easy for you. So we do take advantage of things. So in Python, which in my opinion is the best client library, I also wrote it, but we can take advantage of context managers and decorators. So we can make things pretty awesome. So this is what it takes to time something in Python. You create your metric, give it a name, you give it a help string, because we always want help strings to know what the hell it means, and it's just a decorator. That's it. That's now taken care of. And by the way, this is how you expose things. That single line exposes it. There's your import, there's your pip install. This is a complete working example of Prometheus instrumentation. Of course, it'll only import zeros because there's nothing here, but you know. And also just turn off the end and just die, but this is how simple things are. So you don't have to worry about timing, you don't have to worry about concurrency, all taken care of for you. And you can do exceptions as well. If you want to count the number of exceptions coming out of this code, no problem. If you want to track how many things are inside a piece of code, no problem, we've got decorators for that. Once again, same systems. Now, another aspect that's different about Prometheus, and there are like 5 or 6 other systems out there that have this, is that it doesn't use dotted strings. So any of you use Graphite or anything like that will see that everything's like metric.techweek.tuple. It's great fun. Yeah, like, and sometimes they're careful enough not to put dots into things in here. Not everything is. I'm mentioning no Kafkas in particular. So if you're lucky and someone sanitized it, you can kind of figure out with blobs what's going on and do some munging and maybe make that work. Or, you know, we could actually have key value pairs, like a sane person. So it actually has multi-dimensional metrics. You can have many as you want. Please, not too many. For your own sanity, you don't want too many. And then you can do any aggregations you want based on those. And these can come from instrumentation, so you can specify them in your client code. Or maybe you want to say, hey, no, these machines, that's the production environment, that's the canary environment, that's the pre-prod, that's the pre-prod 2, that's the pre-prod except on Tuesdays, and you can have all these added in and meshed in to make whatever hierarchy and taxonomy makes sense for you. Which is kind of handy when it comes to managing things. So here we have an example from the node exporter. So here's the network received bytes for ETH0 on this machine, and it's the node. And you just can aggregate those any way you want. So the dimensions is pretty easy. It's a small change. Just say here's my labels, and you pass them in. That's it. Extra 20 bytes of code. No problem. So that's pretty simple. The other thing is like, yeah, so we've got all these dimensions. That's great. How powerful is it? What can I do with it? So you can do basically anything. You can multiply, add, subtract, divide, do predictions, quantiles, and you can answer, because to it, it's just a database with a whole pile of key value pairs on metrics. You can do anything you want with it. So if I want to ask the question of, hey, in a European data center, what's on 95th percentile latency across everything, you can. If you want to know, hey, who are the top 5% of CPU users on Docker, you can. If you want to know, hey, how full will my disks be in 4 hours? You can. These are all relatively simple plans. And furthermore, you can alert on any of these. In Prometheus, there is no distinction between alerting and directive expressions and graphing. Anything you can use in one, you can use in the other. You just put a filter on a query, off you go. It's now an alert. If the query returns something, it will alert. That simple. So here's an example of Docker, so we can aggregate up. So you have to take the rate. So the way that Prometheus works, there's a lot of systems out there. What they'll do is that they will, with an exponentially decaying number, track roughly or approximately, it involves calculus, how many queries there were inside the last 60 seconds, and send that once every 60 seconds. So if you lose any of those, you've lost data. Prometheus works differently. We just have counters that increment forever, that are inside the binary, and those are just pulled. So it means if we lose a pull, it's great because network stuff happens. Well, we've lost resolution, but we haven't lost data. We can still see, yes, there are that many queries. And we don't have to use calculus to figure out what's going on. Because exponentially decaying average is like, yeah, let's not do that. So we take the rate, it handles that, it handles resets. We sum it up and get the top 5. There's the top 5 CPU usage across an entire cluster for Docker. Done. Here's a demo. Yeah, did that. So yeah, we can demonstrate more of it than that. Might do that later. So the question of how powerful is the query language? The answer is the query language is Turing complete. How do we know the query language is Turing complete? Because I implemented Conway's life in it, which, if you know, is an automata that is powerful enough to emulate life. People have implemented Turing machines in Conway's life. So yeah, there's a live demo of that if you go to my website, and please do not try this in production. It's just, you know, a little bit of fun. So the other things is that it's great to have all this nice instrumentation, this all powerful system, but if that makes you cry at night when you're thinking about trying to run it, that kind of doesn't work out too well. So what we have is that we try and make it as easy to run as possible. We're following the Unix philosophy. Prometheus itself is a single binary. It doesn't have any crazy dependencies. It needs a disk, preferably SSD, and network access. That's it. It doesn't depend on Zookeeper, console, Hadoop, or anything else like that. Because the last thing you want in emergency is, oh yeah, I've got a network partition, my Zookeeper's gone down, my Kafka has gone down, my monitoring's fallen over, because, well, the network's falling apart. The time when monitoring is most important is when your network's falling apart. So Prometheus is still going to work. It doesn't depend on, you know, any of these sort of systems. And our management module systems out there, like I think Sense using RMQ, that depend on lots and lots of network components. And that's great as long as your network works. It's not so great when your network doesn't work, because then you're blind. So Prometheus is something you can rely on in an emergency, because it's designed to be isolated. And the other thing as well, it's pull-based. So if you just want to go and test it on your workstation, you can. You don't have to go to every single Windows machine saying, by the way, push it over here as well. It just works. If two different teams want to have two different configurations because they've got different taxonomies, they can. Nothing's stopping them. It's kind of handy, it's free. And Service Discovery finds out what you can monitor. So and there is a question, does pull scale? The answer is yes. Push also scales. People who think that you know, one or the other is impossible to scale are wrong. Pull is a little easier to scale. It's slightly better, but you know, we should really stop this flame war. They're both good, they both have their uses, but it's slightly better, in my opinion. So running Prometheus itself, like I have nightly binaries, if you just want to run it. Otherwise you have to kind of set up a Go environment. That's the configuration just to monitor a local machine and run it. So it's pretty easy. It works on like 15 architectures and systems and so on. It's kind of handy. Like everything Go supports, almost. It doesn't work too well on Plan 9. Sorry about that, if anyone's still using Plan 9. I think we got managed to get it working in Solaris again. Anyway. So it's also pretty inefficient, because if you're going to have all this instrumentation throughout your system, you could easily be looking at, you know, thousands of metrics and then split out by however many labels. You could easily be looking at millions of time series. That's a lot of data. So Prometheus is actually one of the most efficient systems out there currently in terms of storage efficiency. We're basically using the same algorithm as Facebook's Gorilla and the new version of InfluxDB. We're looking empirically at about 4.5 bytes per sample, which is pretty darn small. Like, for example, the old Influx was 18 times larger, and that's before we went out for replication. I won't even talk about graphite. A single server as well can handle millions of metrics and ingest them in, and the latest numbers was 525,000 samples of a time series per second. Which, in case you're wondering, is enough to get the machine metrics. We have about 700 metrics we just get from the machine, because like we dump all the network stats. We dump /proc basically. Everything is useful. You can get 10,000 machines worth of that on a single Prometheus server monitoring. So yeah, that's pretty sweet. As long as you don't do crazy and let's say have a metric with cardinality of 1 million, you're going to be right. And it is scalable, like it's easy to run, so give it one to each team. Don't have to worry about a centralized ops group having to go through them. Makes things easier for you to do. You want to test it out in your home system, off you go. If you've got multiple Prometheus servers, you can use Federation to pull data from each of them, use this for rollups. And in the event that somehow you do have several thousand things you need to monitor, and they've got lots of metrics, you can use sharding to scale out. It's possible. Very, very few people actually need this. What's better to do is, hey, front and back end team, you now have your own Prometheus, rather than actually scale vertically that way, rather than scaling horizontally. Very, very few people need to scale horizontally. Like most of you'd only ever see it when it's like, yes, I've got a data center with 10,000 machines, I need to monitor those. You'll rarely see it in applications. There's like lots of integrations, as I mentioned. The really interesting thing about our integrations is that most of these were created without the input of the Prometheus core team. That's how easy they are to create. And also why I wrote a guidelines document on how to write them. Because there's a lot of things that are subtle and good practices, lots of things that seem like good ideas that aren't. But yeah, we've got lots of stuff there. And many languages. There is a bash one, for example, it's not listed there. We have Minecraft support. Yes, you can monitor your Minecraft server. Or syslog, bind, mesos, Django. Kubernetes is not on that list, I need to update it. But yeah, lots of things. There's also plenty of dashboarding options. So we have the built-in one, which is basically just for ad hoc stuff and debugging. We've got console templates if you really like to do your web templates. It's using those templates. Got PromDash, which is a Ruby on Rails app. That's basically deprecated. And because we've gone to using instead Grafana, which is much more standard and has more features. So I'm going to just demo, it's the last thing I do here, I'm going to demo Grafana. And let me fight this. Oh, this is going to be fun, isn't it? Good. Cool. So this is a live Prometheus server, this is the demo. Let's point out, yes, I do have Conway's live. Yeah. Turing complete, I tell you. Cool. So like this, here's the console templates. Like here's the machine stats on this. Yeah. Obviously, it works better on the larger screen. So all these stats here will be done on the fly. Where's my currency? Oh, there she is. Cool. And if you actually want to see what the actual metrics themselves look like, this is the text format. So here you've just got the name, angle brackets, number. So it's a very simple format to write new things in if for some reason you can't use a client library, which is why we have many of them. There's also a protocol format. And there is an alert manager to push game with batch jobs. And Grafana. So this is a company called Raintank produces this. It's pretty common. It supports lots of stuff like Elasticsearch. It supports Graphite. I forget what the other ones it has. Like here we can see our host stats. So here's our user memory, CPU usage, just about all the things here we can get for our machine. I can expand them over time. So I can just look at the last 30 minutes. Those are all there, so that's pretty nice. And add new stuff. I'm not going to try adding new stuff here because I'm not mirrored, and that would be rather painful. So here's Prometheus itself. So you can see this one only has 2,000 time series. And you can see, yep, there's me talking to it there. That's showed up in the graphs now. Because it's actually Prometheus is monitoring itself, just to know how healthy it is. So you can see it's only using, oh, that's me accessing it there. It's only using like 300 megs of RAM, bit of a core. This is all Conway's life, incidentally, is responsible for his CPU usage. Yeah. Otherwise, like this, a single server monitoring itself, it's nothing. You know, like my home Prometheus uses less than this, and that's monitoring 5 servers. Cool. So that's the end. Let's see if we can get back to the actual presentation. So just to recap then, so the things that Prometheus has, there is inclusive monitoring, so like the idea of let's just monitor everything, not just at the edges. We've got the powerful data model with the labels that makes it much easier to have taxonomies and organize and slice and dice as you need. The query language should take advantage of that. It is manageable, reliable, and easy to run. You can just turn it on as a simple Go binary. There's no complex dependencies or anything, you just need libc. It's scalable and efficient if you need it. Like it uses not many resources for what it does. It is like a single server can handle 500,000 samples a second. It's more than you need. It's easy to integrate and there's lots of dashboarding options. Cool. So the website, project website's there. My demo you just saw, I've got my company website too. Are there any questions? Anyone? Yep.
What's the significance of in the game?
So what's the again?
What's the significance of it being able to...
Okay, the question is, what's the significance of being able to run Conway's life? The answer is that Conway's life is Turing complete. So when Prometheus being able to run Conway's life, it demonstrates that Prometheus query language is Turing complete. So basically you can compute anything you want with it, in principle. Of course it's going to stay stuck in a Turing target most of the times, but it is that powerful.
What are your kind of plans for the future, or any kind of features you might add, or at this stage it's kind of just adding integrations and keeping
Yeah, so the question is, what are the plans for the future? Is it new features or just integrations? So we plan on adding more and more integrations over time. In terms of new features, Prometheus is not intended for long-term storage, like beyond a few months. So we want to integrate into something else to handle that problem. Because long-term cluster data storage is really, really hard, and we'd like someone else to solve that. So we want to do that and also the read path back in. The alert manager, the new alert managers, just let's go into a 1.0 release, or at least be officially released rather than alpha. So we want to also make that a HA, because right now it's a SPOF. But you know, having a single SPOF is okay, because Prometheus itself just run 2 of them, point alert manager to take care of it. So that's the sort of thing we're looking at, plus lots of integrations, generally making it better, adding more language features. Yeah, well, most of it's relatively minor. It's just like expanding what we have. Cool. Any other questions? No? Question around the back?
How easy is it to set up if you have a cluster of machines already going?
The question is, how easy is it to set up if the cluster of machines already going? Pretty easy. The real question is, how well are you running those machines? Because the better your setup is, the easier it will be. If you're doing everything by hand and don't have configuration management or machine database, you will have problems. But the problem there is the fact that you're lacking basic infrastructure. If you have basic infrastructure and ask questions like, okay, what are all my machines, what services run on them, it's much easier. Because the real question is you have to produce configuration. So as long as you have those basics in place, it's pretty easy. But if you don't, well, anything's going to be a challenge. There's another question there?
Yeah, what's the business model? Do you have hosting for them, or is it...
Okay. The question is the business model. So Prometheus itself is Apache 2 licensed. So that's a very free open source license, right? My business model is I offer support and consulting services. So a lot of things out there, like you can use it, you can also misuse it pretty easily. And it's not just about having the monitoring, it's about having the practices around it. It's about realizing that even if you do this and has the potential for fixing your alerting and not getting paged in the middle of the night for silly things, knowing how to go about that and how you should think about it Not many companies get it. Because it's like, oh, something's slightly wrong, wake everyone up. It's like, no, let's think about this, let's go through it. And helping companies with that. And how to think about the rollout, how to transition, how to manage it. Any other questions? No, I think we're done then. Thank you very much.